right, so in this example we have a conducting sphere. So we have a conducting sphere that has a net charge of 3Q on its surface. Remember, that could be on the inside versus the outside. Inside the shell is a charge of negative Q. So we want to know what the charge on the inner surface is, so what gets redistributed here, and then what's on the outer surface, so then what gets redistributed to here. Alright, so remember we're going to draw our Gaussian surface, so that inside of that needs to be a net Q of 0, so that our electric field, when we apply Gauss's law, is equal to 0. So since there is a negative Q here, that means to balance that out, we need a positive Q. Alright, so that's what we get here. And because we have originally a net of 3 on this conducting shell, whether it's on the inner surface or the outer surface, and we know on the inner surface it's a plus Q, when we rearrange our algebraic expression to solve for what must be on the outer surface, you get 2Q.